Unit 3, Time Value of Money, Lecture 3, Compound Interest. Now, if you'll note from the previous lecture, I talked about compounding. And if you look at that previous lecture, you will notice that the future value that we were calculating was increasing at an increasing rate. So we started with 100, we went up to 110. In the second year, we went up to 121, and in the third year, we went up to 133. So each year, the interest that we were earning was increasing. So in the first year, we earned 10 Rand. In the second year, we earned 11 Rand. And in the third year, we earned 12 Rand 10. The question is why? And the answer is because we are not just earning interest on our original capital of 100 Rand, we are earning interest on all the interest we generate. So in the first year, we earned interest only on the 100 Rand, so that's why we ended up with 110. But in the second year, we earned interest not just on the 100 Rand, but also on the 10 Rand of interest from the previous year. So every time we earn interest, it becomes capitalized. That means that it gets added to the capital, and for each subsequent year, it gets treated as capital, so interest is earned on that. And that is compound interest. So what this graph demonstrates is that the future value of your investment increases more significantly as the interest rate increases. So if you look at the graph, they start to diverge quite significantly. So if you start with 100 Rand and you only earn 5%, after 20 years you'll have 265 Rand. But if you earn 20% per annum, you will end up with 3,800 Rand. And that's the magic of compounding. So if we look at this example from America, on November the 25th, 1626, Peter Minuit, a Dutchman, reportedly purchased Manhattan from the Indians for $24 worth of beads and other trinkets. Question is, was this a good deal for the Indians? Well, let's look at the magic of compounding. So, if they invested that $24 at 5% for 371 years up until 1997, they would have earned $1.7 trillion. If, on the other hand, they'd invested at 10% per year, they would have earned $54.5 trillion. That is quite something. So according to the Wall Street Journal, it said that all of New York City real estate was worth about $324 billion, and Manhattan makes up about 30% of this, so it should be worth roughly $97 billion. So if the Indians generated 10% and earned the $54.5 trillion, looking at the US GNP, which is $6 trillion per year, this amounts to 9,094 years worth of the total economic output of the USA. So at 5% per annum, the Indians got a bad deal. But if the return was 10% per annum, apparently the Dutch would have been the ones getting the raw end of the deal. But as it turns out, the Indians really had no claim on Manhattan. Apparently they lived on Long Island. And as a final insult to the Dutch settlers, the British arrived in the 1660s and unceremoniously tossed them out. But the point of this whole thing was to demonstrate that given a sum of money and a sufficiently long period of time, you can turn your money using the magic of compounding into quite a substantial sum. We talked in the previous lecture about future values, and we found ourselves calculating the future value using a generalized formula by taking the present value and multiplying it by 1 plus the interest rate raised to the power of the number of years, or the number of periods. Now, if we want to look at finding the present value, then we're really just going to take that formula and turn it on its head. So we're going to now divide the future value by 1 plus the interest rate raised to the power n, and we will have our present value. So over the next few slides, we're going to look at a practical application using both the generalized formula and the financial calculator. So starting with the example, we suppose that you have a 5-year-old daughter and she has just announced her desire to attend college. After some research, you determine that you will need about 100,000 Rand on her 18th birthday to pay for 4 years of college. If you can earn 8% per year on your investments, how much would you need to invest today to ensure that when your daughter turns 18, you have 100,000 Rand available? So using the formula to solve this problem, we're going to start with our future value, which we know is 100,000 Rand. That's what we need to have when your daughter turns 18. The interest that you will generate on this investment is 8% per annum. And you are told that your daughter is currently 5 years old. So you have another 13 years to generate the 100,000. So if we look at our formula, the present value is going to be equal to 100,000 divided by 1.08 raised to the power 13. And we would need, or you would need, to invest a sum of 36,769 Rand and 79 cents today to ensure that when your daughter turns 18, in 13 years' time, you will have 100,000 Rand available for her education. Now, using our financial calculator, we enter 13 for N, 8 for I of Y, 100,000 for the future value. We end up with a present value of 36,769 Rand and 79 cents.